we'll take up one more. So y of t is equal to t times x of t. So solution. Okay, we'll write the system first. So we have a system where input is, we are feeding is x of t, and output from the system is y of t. And what is y of t? T times x of t. We shall understand the system first. If I feed input to the system, what is the output I am getting? So we get the output, we get the input as it is, but for that input signal x of t, t is getting multiplied. And mind you, what is t? T is actually independent variable which takes the value from minus infinity to plus infinity, right? So t takes the value from minus infinity to plus infinity. And how does a t signal looks like? It's like when t equal to 0, amplitude is 0, t is equal to 1, amplitude is 1, t equal to 2, amplitude is 2, t equal to minus 1, amplitude is minus 1. So it goes like this. So till t is equal to infinity, amplitude infinity. T is equal to minus infinity, output is minus infinity. So this signal is getting multiplied with my bounded input x of t, right? So this is what it is doing. Fine. So let us assume that magnitude of x of t, the input signal which I feed, is bounded by a value of bx, and that value is less than infinity. Okay. Then what is the magnitude of the output? Y of t is, okay, so now you have to tell me, is this bounded, which is equal to what? T times x of t, right? For example, if I feed an input signal, this is actually, I feed sine wave. I feed a sine wave, and this sine wave is varying from minus infinity to plus infinity. So even though at t is equal to plus infinity, what is the amplitude of the signal? It remains finite, right? Even though t is equal to minus infinity, what is the amplitude of the signal? It remains finite, right? Okay, so I'm applying the bounded input actually. So and t is also varying from minus infinity to infinity. So I'm applying a bounded input. What is the output I'm expecting? So I'm expecting output as bounded actually if the system is stable, but here in this case, for the bounded input I applied, that input is getting multiplied with t, right? And what is this t signal looks like? This is how it looks like. Okay, now when t goes to infinity, what happens to its amplitude? Amplitude also goes to infinity, and this infinity times the finite signal, it is actually unbounded, no? So it goes to infinity, right? Which is not equal to bounded value, right? If I apply finite input signal, output is not bounded, which is not, when I say it is not equal to by, right? So therefore system is unstable. Okay, I hope you got convinced, but you'll get used to it. Let me solve some more problems on this. So y of t is equal to t by 2. I'll just change it as discrete term. Y of n is equal to n by 2 times x of n. Fine. Okay. So solution. So we have a system which does some transformation. Input to that system is x of n, and output is y of n is equal to n by 2 times x of n. Okay. Now we'll assume that let magnitude of x of n, the input what I am feeding, is bounded by a value of bx which is less than infinity. Then magnitude of y of n, which is equal to magnitude of n by 2 into x of n, is this bounded or unbounded? Okay, again we'll assume we are applying input as sine wave. So at n equal to 0, so it's a sine wave, it's a sample. Okay, so yeah, just imagine that it's a sine wave, but it's a discrete time. Fine. And at n equal to minus infinity, this remains finite. At n equal to plus infinity, amplitude also remains finite. So I'm applying a bounded input, finite amplitude value to the system. But what's happening to the output? So even though if I applied bounded input, finite amplitude input of sine wave, discrete time sequence, but its coefficient is what? At n equal to infinity, x of infinity of a sine wave is finite, but here infinity by 2 is actually infinity, so this goes to infinity. At n equal to minus infinity by 2 is actually infinity, and this goes to infinity. So this is unbounded now, right? So this is not equal to bounded value, bounded output. So therefore system is unstable.